All right, we're doing a short video on fractions and decimals on a number line, and this will be the first time I've ever done a video with a live studio audience. All right, so we're going to start right off the bat by talking about how we plot fractions and decimals and their opposites on a number line. This is very similar to what we would do with a whole number, with integers. And what we're going to do is we're going to look for our number line for the number 2.5. Because 2.5 is directly between 2 and 3, I'm going to plot my point directly between 2 and 3. Now its opposite should be the same distance from 0. So I'm going to do between -2 and -3, and that would give me its opposite. Now we've done before, that little staple that shows that the distance is the same from the point to 0, and you can see that's the same case. I don't want you drawing those staples in, but it does demonstrate that they're the same distance apart. I'm going to make that a little bit darker so you guys can see that that is the same distance from 0. Very good. Now, what we're going to do now is plot our -3.5, and that's going to work the same way, except first we're going to plot our negative value, which is directly between -3 and -4, and then its opposite, which would be a +3.5. Now, the 5.25, which you may remember in class, is a little more challenging because it's greater than 5, but not as big as 5.5. In fact, 5.25 is directly between 5 and 5.5. So here's where 5 is, here's 5.5. So I'm going to plot my 5.25 directly between. And its opposite will find its spot in the same location, again, between the -5 and the -5.5. So that's plotting the points and its opposites on a number line. Another thing we're going to do in 6.3 is we're going to be comparing with less than or greater than. It's very important for us to realize that when we're comparing a positive fraction and a negative fraction, this requires no work at all. We know positive fractions are always going to be greater than negative fractions, and the same thing goes for decimals. If I've got a negative decimal and a positive decimal, there's no need to add a 0 or do anything. It's very clear that -8/10 is smaller than 13/100. All right? The same thing will go into play when we're dealing with comparing to 0. If I compare a -1/2 to 0, obviously a negative number is going to be smaller than 0. And on the same end, if I'm comparing 0 to a negative number, 0 will be greater than that negative number. So there's virtually no work going on. Now, when it's time to compare decimals or fractions that are both negative, this is where a number line can really be a great way to organize our work. So what I would typically do is choose a basis to count by. In this case, maybe I would count by 2/10. So -2/10, -4/10, -6/10, -8/10. And now it's time to plot each of these points. -7/10 would go right here, and -3/10 would go right here. Clearly -7/10 is further to the left, which would indicate that -7/10 is smaller than -3/10. That same concept can be applied with negative fractions, but instead of counting by tenths, I'm going to count by fourths because those are the common denominators. So I'm going to do -1/4, -2/4, and -3/4. Now I know a lot of you know that -2/4 could be written as a fraction -1/2. For our purposes here, it really is fine. All we're doing is comparing them to 0. I can plot my -1/4, my -3/4. I can clearly see -3/4 is to the left, or further to the left, so that tells me that it's smaller. So my correct answer is -1/4 is greater than -3/4. The last example that I want to go over follows the same guidelines, but here I've got different denominators. So with my concern here is I'm going to need to change each of these fractions into a common denominator. So when I change -1/2 and -5/8 into different denominators, I'm looking for the greatest common, or the least common multiple. In this case would be 8. So this would stay as -5/8, and this, I'm multiplying both terms by 4 to get -4/8. So if I'm comparing -4/8 to -5/8, again, I'm going to probably want a number line so I can see my work here. And so I'm going to do 1/8, -2/8, -3/8, -4/8. And you can see I'm not super concerned with my handwriting as much as I am with making sure that I can see where the numbers fall on the number line. -5/8, -4/8. Clearly -5/8 is smaller, which means the correct answer here is -1/2 is greater than -5/8. Same thing with this example, but again, we're going to need to make a common denominator in order to compare. So when I do compare negative 5/6 and negative 7/8, the denominator I'm looking for is 24. As I multiply each term by 4, here I'm going to get negative 20 over 24. And then when I compare down here, I multiply each term by 3, and I get negative 21 over 24. Now this is a scenario where maybe rather than making that big long number line, I'm going to use some logical reasoning. If I was comparing 20 over 24 as a positive number compared to 21 over 24, we clearly would know 20 over 24 is less than 21 over 24. Since we're dealing with negatives, we're just going to flip that sign. And we know that just from some logical reasoning, that means that negative 5/6 is greater than negative 7/8. That'll be the end of our first live video. Thanks for my live studio audience.
Yeah.